arithmetical operations, but we can do some mathematical operations with polynomials. So for the sake of time, I went ahead and printed out the examples there so you don't have to be copying them down. You don't have to worry about missing something. So grab one of the papers from the middle of the table. Okay. Here's the key. Sorry. There's your learning target. Perform operations on polynomials. Mathematical operations. We're talking about addition, subtraction, multiplication, division. That's what we're going to focus on with our polynomials. We're going to start with easy ones, adding and subtracting. It's like when you first started learning how to deal with numbers. You start with adding and subtracting. You don't jump to multiplication and division because it's a little bit more complicated. So we're going to start with addition and subtraction. Okay? Y'all don't struggle with this as much, but some people still do. Variables and exponents do not change when you're adding and subtracting. They just tell you which terms you can combine. You can't combine n cubed and n with addition and subtraction. Now with multiplication, you can. Things change, but with addition and subtraction, exponents do not change. Okay? They do not change. So let's look at this first example. We are told that f of n is equal to n minus 7 minus 5n cubed, and g of n, okay, so that's just function notation, is 6 plus 6n plus n cubed. So we've got two separate named functions. Find g of n minus f of n. So we're taking the g function and we are subtracting the f function. So there are a variety of ways that you can do this. If you're like super OCD, here's what I suggest. G came first, so I'm going to list my terms of G in standard form. I don't like the fact that these are not in standard form. They don't start with the highest exponent and go down to a constant term. So I'm going to rewrite this. N cubed, I don't have an n squared, so I'm just going to leave myself a space. Plus 6n plus 6. Okay? Minus, since I'm subtracting, I'm going to change all the signs in my f of n function when I write them down right here. So my n cubed comes first. It was originally negative 5, so I'm going to make it positive 5, n cubed. This one also doesn't have an n squared. Then I've got n, but I'm changing the signs, so that's minus n. And then I had minus 7, so I'm changing the sign, so it's plus 7. I changed the signs, so now I'm adding, okay? Subtraction is the same as adding the negative. So I changed the sign, so now I'm adding, so all I do is I combine the coefficients. N cubed plus 5n cubed, that's 1 plus 5, that's 6n cubed. Don't have an n squared, so I just skip it. 6 plus negative 1 is positive 5n. And 6 plus 7 is 13. And that's it. Okay, now, a lot of you probably don't need to necessarily put it in this order and change the signs and all that stuff, but it can't hurt. Okay, it's kind of good practice to keep everything straight and make sure you don't miss anything. All right, let's look at number 2. Number 2's got a whole bunch of stuff right here. So I'm not going to read out these functions, but we've got f, g, and h. We have 3 different functions. And they say if f of n minus g of n plus h of n is 4n to the 4th minus, or excuse me, minus, where did minus come from? Plus 2n cubed plus 8n squared minus 13n plus 9, what's the value of a? Well, I didn't read out my functions, so I missed that part. So let's go back and let's find where a is in our problem. A is the coefficient of n squared in our f of n function. That's the only other place I see a, except, you know, in the words what and value. Okay, so that does really good. I'm looking for it in the equations. Okay, so a n squared, we want to know what's the value of a. So we are combining these functions. It's f minus g plus h gives us this result. Well, if we're just adding and subtracting, the only thing we have to worry about are n squared terms. Okay, so only f and g have n squared terms. H doesn't have an n squared. So let's see what we were doing. We were doing f So an squared minus g. So we got to change that sign. Minus 6n squared. We didn't have anything in h, so it's plus 0. You really don't need to write that. Is equals our n squared for the result was 8n squared. So what was a? 14. Okay, a was 14. If you don't see that right off the bat, get rid of the n squares. You really don't need them right here. It's just a minus 6 equals 8, so add 6 to both sides, so a is 14. Okay, a is 14. So here's an example of a problem that's got a whole bunch of stuff to it, and it looks really complicated, but really you've just got to zone in on the important information. They want to know what a is, so you go, you find a, you're adding and subtracting, so you can only combine it with other n squares. Okay, so you just got to zone in on what's important. Okay, make sense? All right, let's go ahead and talk about multiplication while we're at it, because the addition and subtraction is pretty simple. The biggest thing that trips people up is when you're subtracting, the easiest thing to do is change all the signs in that function and turn it into addition. That's the easiest way to handle it. Okay? All right, let's look at multiplication. We multiply our coefficients and we add our exponents. You multiply coefficients and you add the exponents. So, simple example, let's just look at a monomial, a single term distributed to a trinomial. So we're going to distribute the 8b squared to everything inside of our parentheses. Y'all know how to do this already. I'm just going over it for the sake of making sure everybody's good. 8 times 2, 16. B squared times b squared, b to the 4th. Add those exponents. 8b squared times negative b cubed. 8b cubed, excuse me, I left out the 8. Negative 8b cubed. And 8b squared times negative 8, negative 64b squared. Okay, now, y'all ever done one like number 2 before? Binomial times trinomial. Okay. All right, so just to review, you may have set up like a box kind of thing. I don't know how your previous teacher taught you how to do it, but here's how I look at it. It's like number 1, we just have 2 terms that we have to distribute. So we have to distribute the 2x to everything. So I'm going to do that first. So 2x times 3x squared is 6x cubed. 2x times 3x is 6x squared. 2x times 7 is 14x. Then we have to go through and distribute the 7 to everything. Be methodical about it. Don't get all jumbled up. Distribute the 7. 7 times 3x squared is 21x squared. 7 times 3x is 21x. And 7 times 7 is 49. We didn't have any like terms in the previous problem, but we do have some like terms to combine here. 6x cubed. That's the only x cubed term. So we just bring it down. We've got plus 6x squared plus 21x squared, so plus 27x squared. Plus 14x plus 21x, so plus 35x. And then our lonely little constant, plus 49 on the end. Okay? Now, number 3, it's the exact same thing. I just flipped the order. Okay, I just flipped the order. So, there's 2 ways you can look at it. You can just reverse the order, because the order of multiplication doesn't matter. 2 times 3, 3 times 2, you still get 6. Okay? So, same thing's going to happen here, whether it's 4m squared plus m plus 1 times 6m minus 4, or 6m minus 4 times all this, it's the same thing. So, if it really bothers you, you can change the order, or you can look at it the same way. I've got to distribute the 4m squared to both the terms in the second set of parentheses. So 24m cubed minus 16m squared. Then I've got to distribute the m So plus 6m squared minus 4m. Then I've got to distribute the 1. Plus 6m minus 4. If you did it the other way, you should be getting the same answer that I'm getting right now. Just notice, my answer, my like terms are kind of paired up. That's kind of neat. So I've got 24m cubed minus 10m squared plus 2m minus 4. Okay. So it doesn't matter how you look at it, just so you distribute everything in the first set of parentheses to the second set of parentheses, you should be good to go. All right, number 4. 6 minus 2x squared cubed. Anybody know what we need to do there? Okay. I've heard you need to raise everything to the third, apply the exponents. Multiplying the exponents, yes. Wait, no, okay, be careful. Yes, that is the rule. When we raise a power to a power, we do multiply the exponents. But this is not equal to 216 minus 8x to the 6th. It is not equal to that. You don't just cube both those terms. What happens if that was squared? 6 minus 2x squared squared. What do? You square just both the things inside the parentheses? Let's go back a step. What does it actually mean to square a number? You multiply it by itself. So what we're really doing here, if we cube a number or cube an expression, we're multiplying it by itself 3 times. We're multiplying it by itself 3 times. And you'll see here in a second that we do not get 216 minus 8x cubed. Or, excuse me, x to the 6th. All right, so the way to handle this is you pair it up, okay? It's kind of like if I ask you to multiply 5 times 2 times 3, okay? If I ask you to multiply 5 times 2 times 3, there are about 3 different ways that you can do it, right? Some of you would say, okay, well, 5 times 2 is 10, times 3 is 30. Some of you would say 2 times 3 is 6, 5 times 6 is 30. Okay, it doesn't matter what order you do it in, or 5 times 3 is 15, times 2 is 30. Either way, you get 30. So it doesn't matter which way you multiply these. I think it's easier just to, I always pair the last 2. So I'm going to bring the first one down, and I'm going to FOIL. I'm going to multiply, double distribute, however you want to, whatever you want to call it. 6 times 6 is 36. The outside gives me negative 12x squared. The inside gives me negative 12x squared, so that's negative 24x squared. If you need to write out that step, that is perfectly fine. Do it. Don't skip it. Okay, but I've been doing this for a long time. I can skip it. And then the last, negative 2 times negative 2 is positive 4. X squared times x squared is x to the 4th. Now this is just like example number 2. We need to distribute the 6 to everything. 6 times 36 is 216. 6 times 24, somebody help me out with that one. 144. Thank you. 144x squared. 6 times 4 is 24, x to the 4th. Then distribute the negative 2x squared to everything. So negative 2x squared times 36 is negative 72x squared plus 48x to the 4th minus 8x to the 6th. So we do get part of what I told you that the answer was not equal to, the beginning and the end, but there's a whole bunch of stuff in between that we would have missed had we not done this correctly. Let's see here. So that is, if we combine the x squares, that is negative 216. plus 72 x to the fourth minus 8x to the sixth. Did I add those numbers correctly? Yeah, what y'all got if you did it in the calculator? Okay, I know it's not in standard form, okay, but I left it in this form because the original problem had the constant first, so I just kept it in the reverse order. It's fine if you put it in standard form, just make sure that the 8x to the sixth is negative, and so forth and so on, okay? It's fine if it bugs you and you want it in standard form. You can change the order. All right, questions?